All right, calculus, welcome to your section 5.3 review video. This should be a review. We've already evaluated definite integrals. Do write these down though. This is example 1. On the left side, I have the number of the lines written. I kind of have to write these out beforehand, so we're going to do the best we can. Anyway, the example is you're going to integrate. Bounds are 1 to 9. This function here, 3x minus 2 over the square root of x. Independent variable is x. First off, you're going to divide everything by a power of x to the 1/2. So here's what we got. It's now x to 3, x to the 1/2 minus 2x to the negative 1/2. Then it is antiderivative time. Take the antiderivative of that. Remember, 1 power up, that'd be 3 over 2. Divide by the new power. Dividing by 3 over 2 is multiplying by 2/3 minus 1 power up divided by the new power. Dividing by 1/2 is like multiplying by 2. There you go. That is the antiderivative. Now we will evaluate that. The antiderivative evaluated at 9 minus the antiderivative evaluated at 1. Okay, plug that in. When you plug 1 in, it's no big deal. Plug 9 in. You get 42 minus a negative 2. 42 plus 2 is 44. Again, take your time with this. This should be a review, though. Write these down. These are good questions. Chance we might have gone over this last day in class, I'm not sure. All right, evaluate x squared plus x plus 1 all over x dx. And the bounds are 1 to e. Divide everything by x. Now I have x plus 1 over x. Antiderivative time. Remember the antiderivative of 1 over x is natural log x. That'd be x, 1 power up divided by the new power. Plug in e, plug in 1. When I plug in e, that's what I got. Natural log of e is 1. Minus, when I plug in 1, it's 1 squared over 2, which is 1/2. Plus 1 plus natural log of 1 is 0. So we'll be subtracting 3/2. Anyway, there we go. You can also write your answer like this. All right, got a weird lighting change there, sorry. All right, find the general antiderivative integral. Or find the general indefinite integral. All right, so basically, I should probably say evaluate, Anyway, yes, that is the instructions there. What we're going to do is just find the antiderivative. And remember, it needs a plus c. That is the general one. Okay, just like finding the general antiderivative. Anyway, what you got to do first is FOIL. When you do FOIL, you get that. All right. Antiderivative is 1 power up divided by the new power plus c. No bounds, nothing to plug in. On example 4, starting at line 25 there. What you want to do, again, same thing, no bounds. What you want to do is distribute. 1 power up divided by the new power. Don't forget about plus c. These are relatively easy. Number 5, we did one like 5 there, starting at line 30 last week. 1 minus cosine squared x is sine squared x. All right, that's just sine. The antiderivative of sine is negative cosine. That one's not too bad at all. All right, we did that one. Going to put a big old check there. Great. Take a look at the next page. So, this next page does have a new question. The velocity, for us, the velocity function in meters per second is given for a particle moving along a line. Fine. Again, pause this whenever you need to. Find the displacement. We know how to do that. And find the distance traveled during the time period. Okay, we don't know that. There's the velocity function, and the time period is 1 at t. Displacement is s of 4 minus s of 1. It's s of b minus s of a. And to find the displacement function, you just integrate velocity there. Find the antiderivative of velocity. The bounds are 1 to 4, so I'm going to do that. T squared minus t minus 6. 1 power up divided by the new power. My bounds are 4, 1 to 4. Again, this is for total displacement, st2 minus st1. That's what this is. When you integrate, Take the antiderivative of the velocity function, integrate with bounds t1 to t2. Boom, you'll get overall displacement. Remember, displacement can be negative. Anyway, plug 4 in for t, plug 1 in for t. Do a little arithmetic, and boom, -9/2 is my displacement. Now, distance traveled is never negative, so this is something new. The absolute value of v at t, again, same bounds, t1 to t2, equals total distance. If I go 3 to the left, my displacement will be -3, but my total distance will be 3. So what I need to do is, over the time period, I need to know when velocity is negative and when velocity is positive. Okay, so remember the time interval is 1 to 4. So what I do is I look at that velocity function, which is this, set it equal to 0. I want to know when the velocity is 0, when I'm going to change directions. I factor it. T minus 3, t plus 2 equals 0. I get t is -2, and I get t equals 3. Remember, my time interval is 1 to 4. I wouldn't count -2 no matter what, because it's a negative time. So at time t equals 3, something is changing. Either I'm going from the left to the right or from the right to the left. I'm changing directions. So what I need to do is, basically from 1 to 3 I'm doing something, and from 3 to 4 I'm doing something. So if you want, plug 2 in here. If you plug 2, you get a negative times a positive, which is a negative. So from 1 to 3, the velocity is less than 0. Plug 3.5 in, positive, positive. We kind of do this already. So on 3 to 4, the velocity is positive. Okay? So on 3 to 4, I just evaluate the, I take the antiderivative and I use the same bounds. I use 3 to 4. I just treat it as the regular velocity function. But on the bounds, time interval 1 to 3, because I'm going to the left, I want to evaluate here the opposite of the velocity function. Okay, so the opposite will give me a distance that is positive. All right, like on this first one here, notice how my displacement was a negative. My distance traveled would be a positive. See, if I would have put every sign here as the opposite sign, I would have gotten a positive 64/6, and that's what I want. I want a positive distance. Okay, so it's going to be the opposite of the velocity function, or the absolute value of the velocity function. Okay, again, the absolute value will become positive here. So what I got to do is I got to know that because I'm going to have negative displacement here. If I want positive distance overall, I got to multiply this function by -1. All right, so the original function was t squared minus t minus 6. New function is -t plus, or t squared plus t plus 6. My bounds are 1 to 3. I integrate 1 to 3. Integrate, take the antiderivative of this. That's just the regular positive. It's the regular velocity function because the velocity is positive there, so I will get a positive distance. All about getting a positive distance. Manipulate your function so you get that positive distance, not a negative one. Take the antiderivative. They look very similar. They're just opposites of each other. All right, so this is the first function here. This is the one I had to call the opposite. I plugged in 3, I plugged in 1. This is the second function here. I plugged in 4, I plugged in 3. Okay, write this down. Obviously, it's something we're going to continue to talk about when I see you again. You just need to get a few notes about this right now. All right. Anyway, here's all the arithmetic. All right, we get a positive distance of 61/6. So the displacement was -9/2. I ended like 4.5 to the left, but my overall distance was 61/6. Okay, here is another one of those coming up. So first off, example 7. It's going to get better here, sorry. Find the displacement and the distance traveled. There's the function, 0 to t, or 0 to 3. All right, so displacement, again, we know how to do this. Take the antiderivative of velocity. My bounds are 0 to 3. There's the antiderivative of velocity. Evaluate at 3 and 0. Evaluating at 0 is the easiest thing ever. So again, my displacement's a -3/2. 3.5 to the left. Distance traveled is going to be a lot different, though. So I take my velocity function. I want to figure out when it changes. All right, so I set it equal to 0. When is my velocity 0? So my velocity 0 is at 5/3. At time t equals 5/3, there's a transition going on. All right, so I have two intervals. I have 0 to 5/3. I have 5/3 to 3. And if you wanted to, you can just off to the side figure out which is which. I'll get out of your way here. All right, so you got your two intervals, right? So you can put a test value, 1, and you just plug that into velocity function. When I plug 1 in, I get a negative. Okay, so velocity is negative on that interval. And then it's going to be positive. What's the test value for 5/3 to 3? 2. If you plug in 2, you get 1, which is positive. So the velocity is positive on 5/3 to 3. So on 5/3 to 3, I evaluate, I take the antiderivative. I look at my regular velocity function. But from 0 to 5/3, my displacement would be negative because my velocity is negative. So to get a positive distance, I just call it the negative vt function. I just multiply the velocity function by -1. All right, and when I integrate that, take the antiderivative, believe it or not, even though you got that -3t there, I will get a positive distance. Okay? Take the antiderivative. Take the antiderivative. Here you're going to evaluate at 5/3 and 0. There's 5/3. There's 0, obviously. Here you're going to evaluate at 3 and 5/3. A lot of arithmetic there. Again, sorry for the adjustment here. The light's not great when it's dark. Up here in the office, won't usually be using this room, but my daughter might be making noise, so we're up here. Anyway, wow, a lot of arithmetic, okay? So there it is. This goes with this. This goes with that. All right. Then I just did some more combine. You combine it however you want. I tried doing this without a calculator. Anyway, 41/6. 41/6 is my distance. All right, you can pause this whenever you want. Here's an easy one, okay? Just integrate as bounds. 1 power up divided by the new power. If you divide by 1/4, you multiply by 4. Plug it in, you get 4. All right. Now, remember, if your acceleration function is that and your initial velocity is 23, then your velocity function is the antiderivative of acceleration plus c, but c would have to be 23, because if you plug 0 in for t, then 23 would equal c. That would be your velocity function. All right, so that's a good little thing to have down there. And lastly, for section 5.3, then we're going to talk about 5.4. Velocity questions can be maybe more of the tricky ones. They're just a little bit involved. Find the velocity at time t and the distance traveled during the given interval. The only difference here is I've given you the acceleration function, okay? So find the velocity at time t. All right, so that's just the velocity function and the distance traveled. Okay, so the velocity function is the antiderivative. Okay, 1 power up divided by new power, plus 4t plus c. Velocity at time 0 is 5, so c is 5. That's the velocity function. So when they say find the velocity function, it's that one right there. Now, starting at 0 and ending at t. Okay, well, if you set said velocity function equal to 0, what I did is I just doubled everything so I didn't have to deal with a 1/2 for a. If you set that equal to 0, shoot, it does not factor. Nothing multiplies to 10 and adds to 8. Oh no, you tell me I gotta use the quadratic formula. I am. T equals -b plus or minus the square root of b squared minus 4ac all over 2a. Here's the thing, folks. Simplify it up. Both of those values are less than 0. They're both negative, okay? And you can't have negative time there. So velocity is always positive. I'm always going in the same positive direction. You can kind of see that here. Notice how literally everything is positive. The only thing Drag that down to be a negative value. You can have a negative time. Okay, so velocity is always positive. That's easy. So that means my distance traveled, I just simply think about it as displacement, because if I'm just moving to the right, my displacement would be the same as my distance that I've traveled. All right, there's my velocity function. My bounds are 0 to 10. Take the antiderivative. It's really just plug in 10. There's my distance traveled. That one was lovely. And finally, number 10 here to end. My acceleration function, I want the same thing, same question, all right? So I want to find the velocity at time t and the distance traveled during the given interval. Acceleration function is 2t plus 3. Initial velocity is -4. Velocity function would be t squared plus 3t plus c, and my c would be -4. That is my velocity function, so highlight that. I want to know when my velocity is 0, so I set that velocity function, which can factor t plus 4, t minus 1 equal to 0. All right, so the transition that I care about is at time t equals 1, because t can't be equal to -4. So I plug, like, I don't know, a half. Plug a half in here. You get 4 halves times a -half. That'll be a negative velocity. So velocity is less than or equal to 0 on the interval 0 to 1, and it's greater than or equal to 0 on 1 to 3. Really 1 to infinity, but I'm ending at 3 right there. Again, velocity is less than or equal to 0 on the interval 0 to 1, greater than or equal to 0 on the interval 1 to 3. All right, so that means from 1 to 3, just looking at the regular velocity function, t squared plus 3t minus 4. And on 0 to 1, I got to look at the opposite. It's moving to the left. All right, if I want to find that distance, I got to multiply it by, if I want the distance to be positive, I got to multiply by -1. So I take that velocity function, when it's negative, multiply everything by -1. And that's what I got there, and I integrate. All right, there is that antiderivative evaluated at 1, that antiderivative evaluated at 0, plus this antiderivative evaluated at 3, minus this antiderivative evaluated at 1. Again, pause this if you need, and this is just me doing arithmetic, all right? I didn't have a calculator there at the time, so you do whatever you want. Anyway, 89/6. Well, folks, this concludes section 5.3. This would be like, the last ones we looked at would be like one question on maybe your second quiz, one question on the exam, one of the exams for this chapter. Anyway, folks, this is Yak Math Video. Section 5.4 will be coming at you, maybe in a few days or so. You guys got plenty of things to work on right now. Keep reviewing that quiz review 1. Do homework set number 2. I gave you a video for that. And in a few days, we'll get section 5.4. And I do plan on giving you a section for 5.5 over these 2 weeks. This is Yak Math Videos, signing out.